So hello everyone and welcome back to my YouTube channel. So in this one, I'm going to make one web apps for gender recognition using deep learning in Python. 16 December 1971, Bangladesh won against Pakistan, and one new country was born that's called Bangladesh. আর এই টিউটোরিয়াল যারা বাংলাদেশ থেকে অথবা ভারতে কলকাতা থেকে বা যে কোনো জায়গা থেকে যারা বাঙালি দেখতেছেন সবাইকে জানাই মহান বিজয় দিবসের শুভেচ্ছা। আজকে 50 বছর হতে লাগলো আমরা নতুন একটা দেশ পেয়েছি। 1971 সাল থেকে 2021 সাল মোট 50 বছর। আর এটা একটা সুবর্ণ জয়ন্তী, সো আমাদের সেলিব্রেট করা দরকার। So that's why I'm going to create the video. So now let's get started and jump with the tutorial. So for building the model, the dataset that you can use that is called Gender Classification Dataset from Kaggle. So this is a dataset. If I go down, you can see here there's a two folder that's called the training and the validation. And inside this training, you can see that there is two directories, female and the male, and which is actually containing up to 23,000 images. And on the validation, there are directories containing the 5,000, more than 5,000 images. So we don't have any high GPU, so that's why we're actually using this validation part. So let's download the data set, and after download the data set, extract the file, then we're going to actually using the validation one for the testing purposes. If you have more amount of GPU, you can actually using this training one, this one. So let's first download the data set for clicking this button. Okay, you need to sign in on the Kaggle, and after that you can download that. So I will download the data set. So after downloading the data and extract the file, you can actually get here two folders that's called training and the validations. So on the training, you can see here on the validation, there are 5,000 images, more than 5,000 images. So you can actually using this validation one, not training, because we don't have much more amount of GPU. So you actually using this validation. So for that, I am going to actually convert it into one field that's called the data set, and I'm going to actually use here. Okay, so now let's see and jump on the code and how can I actually do that. So all right, so now you can see here I have a folder that's called gender recognition web apps, and also you can see here one folder that's called the dataset, and also one header cascade frontal default.xml file. So this file actually using to detect the faces from our frame. Okay, and you can see here this is a dataset, and the dataset actually containing two classes. So first one is the female and second one is the male. So in the female, it's containing the image of the female, and in the male, it's actually containing the image of the male. So now let's create one Python file here. So first we're going to actually train the model. That's mean you're going to build one deep learning model. That's means CNN model. Then you're going to test it out, and we are going to use that on our web apps. Okay. So let's say main train.py. Okay. So our file is right now created. So now what you can do, we are going to actually create one label for that. That's when you can see your male and female. It's not actually understandable by our machines. So you're going to convert them into some numbers. So for that, you're going to actually convert them into some kind of dictionary. Okay. So the dictionary actually look like that. This is one kind of dictionary with key, value, and pair. So let's say we have the female. So we are going to actually set the female value as the 0. And the male, that's the male, equal to 1. So we can actually make this kind of thing because our computer is actually recognize the number, not the actual text. Okay, so now what you can do, we can actually first converting these classes into some labels. Then you can actually iterate to all the images from the picture, and then you can do some preprocessing here, and after that you're going to build the CNN model. So first I'm going to actually import here the CV2, because we need to actually read the images. So that's why I'm going to actually import the CV2. Then also I'm going to import the OS. So OS is actually help us to do some operating system tasks here. Let's say you can actually make some list of your folder. Okay. So now what you can do, you can actually create one dictionary of the label. That's mean you're going to converting this female and the male to 0 and the 1. So in our data path, this is our data path. So let's initialize a variable that's called data. Let's say data path equal. So our data path is nothing but called data set. Okay. So now what you can do, we are going to actually iterate to all the classes from here. So this is nothing but our category. So now we're going to actually create one list for that. So for that, our OS actually help us to create one list. So let's say os.listed. Okay. So inside that, I'm going to pass here the data path. Okay. So these are nothing but our classes. Okay. You can say here, let's say class. Okay. That's our classes. So let's make it the classes here, because class is a keyword in Python. So don't use that. Use the keyword as a variable. So if I'm trying to print the classes, okay. So let's see. So just open my terminal here, and I'm going to type here which one, main train.py. So make sure that your file should be saved in VS Code, or you can also use the auto save here on. Okay, it automatically saves the file, but it's better to save the file. Okay. So when I run the code, you can see here we got two lists. One is a female and the male. So female and the male is actually coming from this data set. Yep. So that's means we are going to create one list here. Now we are going to iterate through all the classes from here. Okay. Then we're going to create one dictionary. That's means male and the female. So now let's see how can we do that. So we're going to use one list comprehensive here to make it easy. So let's say I for I in, okay, range. Okay, so length of which one? Length of the classes. So this actually give us the index. That means this is the first index or the second index. So this line is actually for indexing that how many classes here, okay, or one or two. So it actually give two value. Why? Because female and male. So now we will actually assign into one variable. That's called our levels. Okay, so that's our nothing but our levels. Okay, so now if I try to print the levels, that's in these levels, let's save it and Control C and Control V and run it. You can see here 0 1. That's mean actually give us 0 and 1. So now we got our list and also we got our levels. So now we're going to merge them, female to 0 and male to 1. Okay, so now let's see how can we actually merge that. So for actually merging that, we are going to actually zip that. So let's zip. So we're going to zip which one? We are going to zip first our classes and also our levels. So in which format? We're going to actually convert this into diction format. So let's say dictionary format, simple. Okay, and now we can actually store in our variable. So this our nothing but our level dict. This one, simple. Okay, so now if I try to print it out, so let's say try to print the level dict. Control C, or say Control S, Control C here, Control V. You can also run that from here, and you can see our female is 0 and male is 1. That's means we're converting our folder, this folder to 0 and this folder to 1. You can actually do it dynamically, but it's little bit different here because I also cover one playlist for deep learning for healthcare. So in this case, I'm not actually using here. So just use 0 and 1. So I think that it is very better to actually make some cool thing. So now it's done. So now what you need to do, we need to actually load the data. Okay, let's load the picture from here. So for loading the data, you're going to actually use the OpenCV. So for the time convenience, actually I am going to paste here some code because this is so long code. I think you can actually understand here because I'm going to discuss about this thing one by one. Okay, so this part is nothing but for our which one? This called the make. So we make the level as a dict right now. So now what you need to do, we need to actually load the data. Okay, this one. So now let's see how can I load the data here. So now it's time to actually load the data from our directory because we map that. That's when we actually make one dictionary here. So now I'm going to paste here some code to load the data from our directory. Okay, so this is the code for actually loading the data from the directory. So let's see. So first we're going to initialize the image size as 32 because we are going to actually convert this image into 32 by 32. Okay, then we create two empty lists. First one is for data because we are going to actually convert this image into numpy array. Then after that, on the corresponding data, we are going to actually set here one target that is 0 or 1 that you're actually getting from our level. Okay, then you can see here face data, and we are going to load the header cascade front on default.xml file, and you're going to pass here the cascade classifier. So this cascade classifier actually detect the faces from our images. So but in our case, if I see one picture from here, let's say this picture, but this picture is already cut. That means this is already pre-processed here. But sometimes if you are actually using some big picture with some negative images or positive images, so this time it actually cut the frame. So that's why I'm going to load here. Okay, right now I'm actually using the Kaggle dataset, but in this case it's already done. But when if you're trying to do some custom data, you're actually using this one custom data, so make sure that you use this one. It will actually detect the faces from your picture and cut them and store into one variable. Okay, so now we're going to iterate to all the classes from here. We have two classes, so that's why we going to actually iterate to all the classes from here. Then after that we are going to join the path. This data path is actually look like that. For that, let's assume that this is our data path. Okay, this is our data path. Now you can see os.path.join and then categories. So categories, how many categories have we? Have two categories. So first one is our female. So first it will go on the female, that's mean in this directory. Then what you can do, you can make one list of the inside the female. Okay, that's mean inside the female, that's mean how many picture here. So done, it actually make the list of them. Now there are nothing but our images. Let's say this is the image of, let's say one name, let's say name dot, let's say jpg, simple. So that's mean it actually go here on the data set. After that it actually joining here the path, joining the category, that's mean category the female or the male. Then after that it actually make one list inside the folder, that's mean list of all the picture. So there should be maybe 5,000 pixels, that's mean 5,000 different images. It actually make this kind of list here. Okay, then it able to actually read all the images through here. So that's why it actually iterate to all the images from the image name. And after that we are going to join them, the folder path to the actual path. Okay, then it will actually load the images from here. Okay, you can see here this is nothing but our actual image path, folder path and the image name. That's mean it actually iterate to all the images, then join them and create one actual image path. It will look like that's data set and go to the female and read the images and give us the image path. Okay, I think hope sense to you. Then it will read the images, and after reading the images it actually detect the multi-scale. Okay, you can pass here some value for detecting the faces. Then what you can do, you can actually iterate to all the x coordinate, y coordinate and the width and the height of the images. Okay, then it will cut the picture. You can see a subtext face equal to image, and you're going to cut them into y to y plus height and x to x plus y. That's mean actually cutting the picture. But in our case it's already pre-processed. You can see it's already pre-processed. That's mean actually cutting all the picture when the face is actually detected. So let's go on the paint and you can actually understand it very well. Okay, what I'm actually talking about. So now let's assume that you have a picture with background. In the data set that you're actually using, it's already pre-processed. That's mean you actually cut the picture, that's mean subfaces. But in here you can see some background. So what it will do, it actually detect the faces first. That means the hair cascade actually detect the faces first. Then after that it actually cut them in subfaces. So this is our x-axis, this is our y-axis, and y-axis actually go to the height. That means this is our height and this is our width. That means y is go to the height and x is go to the width. After that it will cut them. That means y to our height and our x to our width of the images. Then it will cut them into some subfaces. If we actually set them some picture like that on the mail, the mail folder, it actually cut them the picture and save it into our data list and with corresponding target, that is a female or male, coming from the female folder or the male folder. So that's the basic thing here. So now let's jump on the code and see that how can we actually save it on the data list. Then after that you're going to convert this subface into grayscale images, because you know when the CNN model actually train the model in the grayscale mode, so it's so faster, it's actually faster training. Okay, so that's why we're going to actually resize the images. Why resize? Because we're going to actually resize the image by 32 by 32. Okay, then we're going to append the data. append the images and the corresponding label. That's mean, for example, first the value or first picture actually coming from the female. Let's say first picture actually coming from female. So female level is nothing but 0, and male level is nothing but 1. So what it actually do, on the data we are going to actually put the picture of the female, and the target we are going to actually put here this value 0. Okay, so how it actually come from the male picture, so it actually append the data into male picture. That's mean data, this list as a numpy array. Actually images are represented as a numpy array, and after that in the corresponding target it actually set here. That's mean this actually list look like, that mean one picture, let's say one picture, okay, and corresponding target like that. Okay, but in picture there should be so many multi-dimensional array. Okay, so our image loading is done. Okay, so now what we can do, we are going to actually save the file in some numpy model. So how can actually save that? Why we are going to save that? Because we have 5,000 images. So when actually run the code, it will take maybe 5 to 10 minutes. Okay, 5 to 10 minutes actually load the images from the folder, because it actually load the images, then actually see the images, then it will resize the images. After that, it will actually append all the data here. So now if I run the code again and again, so when I actually run the code for the first time, it will take 5 minutes. After that, when I get some error, so it will take 5 minutes. So it will take much more time. So that's why you can actually save this data and the target in one kind of numpy array. So after that, when we can actually remove this code, after that we are going to load the numpy array from here. So now let's see how can actually save that in numpy array. So now what we can do, we can do some pre-processing of the images. We're going to convert this image into numpy array, then we are going to normalize the images, then we also reshape the images based on our CNN model. After that, we're going to save that, because we are not actually doing this multiple time when actually load the model or load the picture from your folder. So definitely it will take time. So when actually do the same thing for again and again, so it will actually time consume. So for that, you're going to actually save this file into one kind of numpy array. So for that, I'm going to actually import first numpy as np. So this is nothing but called the pre-processing part. So let's do here. So this is called the, let's say, pre-processing part. Okay. Okay. So we're going to load the numpy array, numpy np dot import numpy as np. Sorry for that. Okay. So now I'm going to convert the data into numpy array, because this is right now image, not numpy array right now, but it represents as an array here. Okay. So now what you can do, we are going to convert them into numpy array. So now let's see np.array. Okay, inside that we are going to pass here our data. That's this data. Okay, and we are going to divide by 2550. Why 255.0? Because pixel is start from 0 to 255. That's mean black pixel and the white pixel. So highest value is 255. So when actually divide by 255, so all the value range should be 0 to 1. Okay. So now let's store into the variable that's called data. Okay. So we normalize our data right now. Now what you can do, we are going to reshape the data. So why the reshape? Because our CNN model actually take this kind of reshaping purpose. So the reshaping technique is nothing but your length of the data, or length of the data, you can say length of the data. That's been how many images here. Okay, then the image size, again image size, and number of channel. So you have number of channel 1, because we converting this image into grayscale. So this will actually look like that. So now we can reshape that simply. So let's comment out this line. So now we're going to reshape here. So let's say np dot, we're going to reshape here. So that's a reshape, and inside this reshape we're going to pass here our data. Okay, So let's see, reshape will take one first one A and the new shape. So we're going to convert this data into one new kind of shape. That's in this kind of shape. So let's say data. Okay, so data. So our shape is coming from here, from our data. That means this is our shape, and now we're going to pass here our image size. Let's say in our case, this is our image size, and again the image size. Okay, and after that the number of channels. So number of channels we have 1. So now let's store into the same variable that's called data. So now we are converting this data, that's an image, into NumPy array. Then we also normalize by 255, dividing by 255, and also reshaping the data. So now we need to do the same thing for the target. Okay, so let's say target equal, so np.array. Okay, and let's pass here the target. Simple. So our target is also converted into NumPy array, but we don't need to actually normalize them because it's already normalized. But we need to also actually make this into one-hot encoding. That's in categorical format. Okay, so let's say from keras.utils. I'm going to import here. Okay, import and utils. Okay, it will do the one-hot encoding. So one question also actually coming from a subscriber, that which version actually I'm using here for the Keras or TensorFlow. So let's actually type here Python. So let's say my Keras version. So this is my Keras version. Okay, I think, okay, sorry, I need to import here first Keras. Then after that I'm going to actually make the Keras dot underscore version. Okay, just take some time because it loads here. So Keras dot underscore version. So you can see here this is my Keras version 2.4.3, and also let's check my TensorFlow version. So let's say TensorFlow as TF, and let's say TF dot underscore version. So this is my TF version. Okay, how you need to run the program. So make sure that using this version. Okay, so now we need to convert them into one-hot encoding. So let's say np. Okay, so no, sorry, np utils. Okay, dot to categorical. We're going to make this into categorical format. So let's say target. So this is our new target. Okay, let's assign into one variable. Let's call new target. Okay, so our done is right now work here. Okay, so now what you can do, we are going to save here in one kind of file. So let's say np.save. So we're going to save into one folder. Let's create one external folder here. Let's say training data or data, let's say target. Okay, this one. So this is our folder name. So let's pass here the folder. Okay, let's say this one. So our training, okay, this is our training data target. Okay, so make sure that your folder is correct name. So training data target, and inside this we're going to pass here the data. That's mean this data, and after that you'll pass here the data. Okay, this is error. And also we're going to save the our corresponding target. So this is our target here. So this target is our nothing but this target, and this is our new target. So let's paste it on here. Okay, so now it's time to actually load the data and save it into NumPy array. So when the loading of the data is successfully done, then we can remove the code here. Then we can actually using this NumPy data on the later on. Okay, so this is the basic things that you need to do here. Okay, so now it's time to actually run the program. So terminal, go here. So Python, so main train.py. So definitely it will take much more time to actually load the data. So I'll pause the video and I'll come back again when the actually loading is done. So now you can see here our image loading is right now done, and if I go on the folder, you can see there's a two files that's called data.npy and the target.npy. So now what you can do, we can actually load the file from here. So now we're going to actually create one extra Python file to load that. So let's see, this is the technique that you can actually use when actually loading the images here. That's big images. So let's say main train, let's say this is view 1. dot pipe. Okay, so now first I'm going to import here. So first I'm going to import here numpy as np, and now I am going to load the data. So let's say data equal to np dot load. Okay, so np dot load, and inside this I'm going to pass here the path. Okay, so path is nothing but our which one, training data target. Okay, so target, and after that we're going to go here and data dot npy. This is the extension, and also we need to load here the target one. Okay, this target. So this is our target. Okay, so now this is called target. Simple. So if we're trying to print the target, okay, let's say target, this one. Now let's see, terminal, and type here python main train 01.py. So you can see here right now, you can see here some corresponding value 01 10 01 10, like that. That's mean our data is right now loading. So we don't need to actually run this script again and again. We are going to actually save that into one numpy array as a preprocessing format. So now can I actually use this data? Now it's time to actually split the data into some format. So for that, you can actually import the sklearn. So sklearn preprocessing. So you're going to import here train, test, and split. So now we're going to actually train, test, and split the data. Okay. So let's say train, test, split, and you're going to pass the data and our target. Okay, and our test size. So what should be the test size of our train, test, and the split? So for that, you're going to train the split the data into 0.1. So let's say this is called test size. Okay, so our test size, let's put here 0.1. That's mean 10% data. You can also use the 20% of the data. Okay, no problem. So let's sign into some variable. Let's say call first one is a train data. That's mean it actually return here four value. So first one is the train data, and second one is the test data, and the third one is the train target, and the last one is our test target. Okay, you can also print it out here. So let's say print, okay, sorry, print the train data, let's say data.shape. So let's print it out. Sorry, Control S and terminal, and I'm going to make here python main train, okay, sorry, 01.py. Okay, just take a while. Okay, cannot import the train the split from sklearn. Okay, that's not pre-processing, that's our model selection. Okay, that's my mistake. I'm going to copy that code here and paste it here. So now you can see here, this is the shape of our images, and this is nothing but our number of images, and this is 32 1. That's mean it's really shaping the data. Okay, because in the pre-processing part, we actually reshaping the data. If I go down, you can see here reshaping the data. So now it's time to actually build the model. So our model, that's been CNN model. Okay, so now let's see how can we actually make this CNN model. So now it's time to actually build the CNN model. So for that, you're going to import some library here. So you can see here from keras.models, you're going to import the sequential, because you're going to make this model as a sequential. Then from keras.layer, you're going to import the dash layer, activation functions, and the flatten and the dropout. The dropout actually using to reduce the overfitting and the library problem in the CNN model. That's the deep learning model. Then from keras.layer, you can import the con2d. So con2d actually using for building the CNN model. That's mean for the convolutional operations. And from keras.callbacks, you can import the model checkpoint. So we will discover that on the later on the model checkpoint, how can actually choose the best model. So now what you can do, we are going to actually initialize some number of filter and the size of the filter 1, the filter 2, just means our kernel size. So you're going to use the kernel size of 3 cross 3, and the size of the folio you're going to use as 2 cross 2, and the number of node you're going to use there 64. So now this is our first layer. So I'm not actually going to the live coding here because it will time code, it will take much more time. But don't worry, I'll put all the code in the description. You can actually download here at the GitHub link. Okay. So now you can see here, we actually initialize here one sequential model. After that, you're going to actually add the conv layer. After that, you're going to actually add here the conv layer. So you can see here on the conv filter, you're going to pass it 32. So 32 is nothing but our which one? This our image size. That actually coming from where? So it is coming from our this one, this preprocessing. So during this file, so we are in file because we load the data already. Okay. Then after that, you're going to pass here the input shape and the first layer. This is the input layer, and after that, it actually get the output layer on the later on. So input shape, you're going to pass a data dot shape 1 0. So 1 colon is nothing but actually coming from 32 and 32 and 1. That's mean this shape. Okay, 0 and 1. After that, rest of that 32, 32, and 1. And for the activation function, you're going to actually using the rel activation function. That's going to actually give us 1 or 0. Then after that, you're going to add another convolution layer of the 32. That's been 32 filters. Then after that, you're going to actually put here one max polling layer for the polling operations. And after that, you can actually add here the filter of kernel size as the 64. Okay, if I hover over here, it will take one first filters. That's been 64 filter. This is our filter. Okay, and this is our kernels. Okay. And the activation function, you're actually using the rel activation functions, and same that this is for the 64. That's been 32, 32, again max polling, 64, 64, and the max polling to actually overcome the model overfit or underfit. You can actually add here one dropout at the 50%. That's when actually deactivate the 50% of the neuron from our model. Then after that, you're going to flatten that. Simple. It is a simple CNN model here. So after that, you're going to actually make this in a vector, flattened vector. That's mean linear vector. That's mean all the actually right now all the images is right now in one kind of multi-dimensional array. So you're going to actually convert that into one flattened. That's mean on one linear layer. Then after that, you're going to pass here on the dance layer. So number of node. You're going to number of node that in our case number of nodes maybe 64. Yep, you can see here 64. And after that, you need to pass the activation function as a rel activation function. Then to pass you one dropout here for actually overcome the overfit or under problem. And the dance layer, you can pass here 2. So why 2? This 2 is nothing but our length of the class. That's mean how many classes here. So you have 2 classes, female and the male. And our activation function is right now soft max. So why soft max? For this kind of output, you can actually use the softmax or the sigmoid activation function. So because this is the categorical cross entropy, if I go here, you can see here we're actually converting this into the categorical to categorical. So that's why we pass here the sigmoid activation, not sigmoid, softmax activation function. Okay, and now it's time to compile the model. So model will compile, and the loss is categorical cross entropy. Because we actually are converting this target into the categorical format, so that's why we're going to make the loss as the categorical cross entropy. And the optimizer, you simply use the Atom optimizer. It's very popular. And the matrix, you're going to use the accuracy matrix. So now we can actually show the summary of the model. So let's say print the model dot summary. Okay, so you can actually print the summary of the model. So let's use this one. Control C, Control V, enter. Okay. So to load all the library here, and it will take some time to load that. And you can see here we got one error maybe. Okay. Okay. This is our sequential object. Okay. Okay. Summary is one kind of function, so that's why it actually giving us one object. You can see here. This is one kind of object that actually get here bound method model or summary. So now let's see, it actually give us the model right now. Just a while. Okay. Yeah, right now you can see here this is our model. Okay, so it will take here the image 32, how many parameter, it will convert. Then after that you can see a dense layer, how many dense layer, and the total parameter and the trainable parameter. Okay, so now it's time to actually compile the model. We compile the model already. Now it's to actually train the model. Okay, so from training the model, we are actually using the model checkpoint here, because we need to check that how the model is actually work, and also we are going to save the best best accuracy model. Okay, so now it's time to actually train the model. That's been our model training part. Okay, training. This one. Why my control is not working here? Okay, so now this is the code for actually saving the model as a checkpoint. So you can see we actually set here one checkpoint here, and okay, this should be our target. Okay, target, this one. So this is our full directory. Inside this we are going to actually save the model, and after some epochs, and if I go here, it actually monitoring the validation loss. So it actually monitoring the validation loss. If this is low, then it will save the best one. You can see save the best only equal to true, and the mode is auto. That's mean actually automatically save all the model which one is best regarding the validation loss. And after that you're going to feed that the train data and the train target and epochs 20 epochs. Let's see the 20 epochs. And after that, in the callbacks, you're going to pass the checkpoint, and the validation split is writing about 0.2. That's mean 20% for the validation, and you actually set here the training. That's mean our train data split you actually set here maybe 0.1. No problem. So now it's time to train the model. So I'm going to actually open the terminal here, and I'm going to type here Python main train 01.py. It will take a while to train the model. So now you can see our epoch is right now started, and you can see the accuracy also is increases and loss is also decreases. So I'll be back here again when the actual training is done. So all right, so now you can see our training is done right now. You can see our accuracy is nothing but 97%. Wow, that's great. And our validation accuracy is nothing but 94%. That's enough good. Okay, so now it's time to actually test the model, that our model actually working fine here or not. So this is the part number 1, and in part number 2 we are going to actually testing the model and also building the web app from the scratch. Okay, so hope you enjoyed this video, and make sure to subscribe my channel, and don't forget to hit the bell icon for never miss any update. And I'll be back with another tutorial. So till then, take care and bye bye.